Okay guys, welcome to another video, and today I'm going to solve this integral. Of course, we need to solve integrals with creativity, not just solve with 2 pages without any sense, no creativity. And today, of course, I bring this because I solved this using some tricks, creativity. So I hope you like, and let's go for what matters right now. So first of all, I'm going to do something. I don't know whether you have thought about this before. I'm going to divide both the numerator and denominator by x². So if we divide this, what we get? We get 1 minus 1 over x², this, right? And here I'll just divide by x, right? And here it be only by x. Here I just let it being divided by x². So here of course we'll get x plus 1 over x. I put the parentheses here, so what I get is this, right? Yeah, 1 over x to the power of 4. Good. Next, what I'm going to do here, I'll keep this, but now I want to do something. This 1 over x can go into the radical. So what you get if you put that, if it gets into there, so what we get here, we get 1 over is x² plus x² dx. So I did that just for one reason, because I can say this, I can let 1x plus 1 over x equal u. So good. And what next, I can say that du is 1 over, if we differentiate this, we get 1 over x². And another thing is that if you take 2x exponent here, you get what? You get u² plus x² is what? Yeah, or 1 this plus 2. Good. So what I get here, this is this is the x here, right? So all this is du, all this is du, and this is u, and of course this, what is that? If you take these two or subtract both members by -2, what we get? You get u² minus 2. Yeah, good. Every fucking time that we are dealing with this kind of integrals, that we have, for example, here we have a radical square root, square root, and here we have it's x to the power of 2, sometimes, most of the time, some to the power of 2, or u, but in this case is u, as we are working in terms of u. We are going to use that is trigonometric substitution. So before that, I'll draw a triangle for this case that we are going to use. I'll draw this triangle. Good. So I can let this equal it be theta. Our cathepha's, here we get u, right? I'm going to put this like this so that we can analyze better. Our hypotenuse is u, and here we get u, right? From here we can start getting our new expressions, in terms is, using trigonometric functions, So our secant of theta will be u over square root of 2. Most of the times that we have this kind here, I can use this and add tangent of theta is equal to what? I'll keep this like this, is -2, right? This over, is square root of 2. Good. and du, add du. Of course here, for example, it won't be great to differentiate this. Look at this square root here. It's much easier to differentiate this expression here, and most of the times we do this when we are dealing with this type of when what we get inside the square root, we have this. So most of the time we are going to differentiate. This is secant of theta. So if you differentiate this one, what do you get? You'll get du. Here it's, and it goes there. And if you differentiate secant of theta, what do we get? Yeah, we get this d theta. I don't know whether it's enough. It's enough. Yeah, of course. Yeah, it's enough. So we can go back to our integral right now. This one. So I can do this. Du it's equal to this. Secant of theta, tangent of theta, d theta. Ru we get from here square root of 2 secant of theta times this is equal to this one is square root of 2 tangent theta. Now I can do something that you really like. Do this. No, this keeps here. Yeah. Sorry for that. Sorry, this. So what do we get here? We get 1 over this d theta. Good. So yeah, we get this. It's theta, right? I won't put plus here right now because our integrals, the original integral is in terms of x, not of theta, so I won't put it right now. Of course, this theta, I can use this. There's two ways. I can take the inverse of secant of theta, but I don't like it at all. So perhaps I can use cosine. Cosine is good. Cosine. Yeah, we can use cosine. Take some. We can do whatever you want. Take the inverse of this, perhaps this, but I will take cosine. Cosine of theta it's equal to what? This it's equal to this over u. So if its inverse is, of course, we can say theta is cosine. The inverse of cosine is this, right? It's this. So theta it's equal to that. So coming back to our integral here, we gotta get 1 over square root of 2. Here is the inverse of this. Here we get this. And then if move on, it's 1 over this. Then is cosine here, the inverse of cosine, and u, I said that it's this u for us. So what I get here, it's square root of 2 over x plus x here. So now I can put plus c. Yeah, basically it's like this. You can do some operations that here multiplied by x square of 2. Same difference. We could even use, for example, the inverse of this or the inverse of this. There's no problem. So guys, see you on another video.